So, thank everybody for showing up to hear about the history of one of the most important commercial failures of all time. The environment that is modern desktop computing kind of owes, in large part, itself to what we're going to look at today, which is the Apple Lisa. And boy, oh boy, it's a story. So, those of you that are already familiar with the Lisa, you may recognize the machine that's up there, the Xerox Star. In 1978, the Apple team was trying to figure out what would be the best way to follow up to the Apple II line. And everybody kind of arrived at the conclusion that, oh, a business machine would be the best and logical next step, because while the Apple II has had success in business, especially with the advent of things like VisiCalc, it wasn't really a business-oriented machine. And so they started looking into what they could do to meet that market's needs. And as a result, Steve Jobs in '78 had some things demonstrated at the Palo Alto Research Center by Xerox, namely Smalltalk for the Star, which was its operating environment. And he decided the Apple team needs to see this. So he arranged for, I don't remember how many shares it was, but he basically gave Xerox a non-trivial amount of Apple shares to arrange for a demonstration of some of the, at that point, then unreleased technologies that Xerox was developing to the Apple team. And the Star and its desktop operating system was the primary focus of that. The two things that we got out of the Star were what we, I guess, still call WIMP, Windows Icons, Menus, and Pointer, and that's still how desktop operating systems work to this day. That philosophy has never left us, and it probably never will, unless you're a Linux user, in which case, I'm sorry. And the desktop metaphor, which is the design term for the desktop interface and visual environment that we're used to today. Why wasn't Xerox doing anything with this? Obviously, if you say the word Xerox, the first thing that comes to pretty much, I'm sure, everyone's mind in this room is photocopiers. And that is because Xerox management was kind of like the dog that caught the car. They had no idea what to do with anything that they were developing. They basically gave Park money and time and said, just figure out the coolest stuff you can. And then they promptly failed to do anything with it. So much to the point that Bill Gates, in, I think, the late 90s, I'm paraphrasing, I apologize, somebody asked him about that. And he said, if they had actually decided to capitalize properly on the stuff that they were researching in the late 1970s, they should have been the Microsoft of the 90s. That is the position in the market that they should have occupied. Because Ethernet was developed at Xerox. Like that is the extent of stuff that they were working on. And it's ubiquitous now. But you're not going to find any Xerox branded NICs or switches or anything like that. So they screwed up. And as a result, Steve Jobs immediately saw this technology and realized this is where everything is headed. If Xerox is not going to capitalize on it, we are. And out of that, we get the Lisa. So in 1979, after that demonstration occurred, development on the Lisa began. And it was the actual planning and early design stages took a couple of years. And we'll get to this in a moment. The actual design cycle where everybody sat down and started working on software and hardware was much more accelerated than the initial planning stages. The three guys you see here, and one of them not pictured, Wayne Rosing, who was the technical lead on the project and maybe one of the most important people associated with the Lisa, who you've probably never heard of. Some of the other guys you may have, Larry Tesler, ex-Xerox employee, got fed up with their inability and incompetence to move any of their technologies into the public realm, decided, screw it, I'm going to go work for Apple, because they know what they're doing. And he left Xerox, and he actually was the lead developer on the Lisa operating system. You all of the stuff that the desktop environment operates on, he brought that knowledge out of Xerox and straight into Apple. Bruce Daniels, who is, I believe, yes, he is the gentleman on the left. He developed all of the system applications. He was the lead app developer for the Lisa. Not pictured, Bill Atkinson, who I'm sure a lot of you know for developing HyperCard. If you're familiar with that at all, if you're not, it should have been the World Wide Web if he thought to add a network stack to it. So he's an important guy. He also developed QuickDraw, which makes the Mac OS, when it was new, what it was. It could, and we'll touch on that in a minute, what QuickDraw was able to do. Now we're at the point where we talk about the actual development. The three main Lisa teams, hardware, software, and applications, or sorry, hardware, OS, and applications, they were all designed in parallel in 6 months. That is, planning ended, and 6 months later, the Lisa was not this, but it was a prototype that did everything that this can do. That is how fast it went. It cost $50 million to develop. I will preface the end of, I'll spoil everything a little bit. They did not make $50 million on the Lisa. I don't think they made $10 million on the Lisa. It was an unmitigated financial failure. Now we get to the part where we talk about Bill Atkinson and QuickDraw. These are Polaroids that Bill Atkinson took of halftone image renderings on the Lisa. This is a Lisa doing this in 1981-ish, which the resolution that you're seeing here is, personal computers just couldn't do that then. Bitmap graphics were not far off in the future in the way that we know them today, but doing halftones at that resolution was still amazing. And this is all QuickDraw managing this. And the other side of QuickDraw was it also handled the windowing system. And the, not pictured here, if you were going to draw a shape like an oval-shaped button or a circle or a triangle or anything, QuickDraw was managing that. It was fast, it was incredibly capable, and it was built by a really capable guy. Steve Jobs basically told, this is an apocryphal story, but I'll tell it real quick. Bill Atkinson presented QuickDraw to Steve Jobs and said, hey, I'm done. And Jobs was going through the capability of shape drawing that QuickDraw had, and he noticed it can't do rounded corners on rectangles. It needs to do rounded corners on rectangles. And Bill Atkinson said, no, that's stupid. Nothing uses that. And so Jobs made him go on a walk with him, and he was pointing out road signs everywhere that just were rounded corner rectangles, and Bill Atkinson acquiesced and built that in. The reason why he didn't originally want to do something like that is there's a lot of extra math, which consumes a lot of extra system resources, slows things down. He got it to work just as fast as everything else. It took about a day of work to make that happen. And the QuickDraw implementation that you see on the Lisa is virtually identical to the QuickDraw implementation that we would get on the Macintosh. But it was not as fast, and we'll get to why that is in just a moment as well. Hardware development. So it has no dedicated MMU. It just uses discrete 7400 series logic. And I don't know how it works.
Neither do I.
He's an electrical engineering student, and he doesn't know how it works. It's kind of complicated because...
Exactly.
Yeah, yeah, it's magic. The nice thing about it, though, is... Well, I don't think I actually included this in notes. The nice thing about it was it implemented a... No, it's later in the presentation, but I'll just say it now. The nice thing that it was capable of was protected memory, which no personal computers or workstations really had that up to that point. The Lisa kind of introduced that concept. And the MMU that they implemented was this big clunky thing. And the reason why it didn't get a discrete MMU is Motorola didn't make one at the time. They went with the 68,000 CPU, but they made no accompanying MMU to go along with that. So that is why they had to implement it in discrete logic. Now, Why was QuickDraw slow? The CPU was slow. The Lisa used the 5 megahertz version of the 68K, which is the slowest 68K Motorola manufactured. And they did that because of price, because the 8 megahertz was available, and they could have used it, but it would have been substantially more expensive. However, by the time the Lisa finally came to market, the 8 megahertz CPU cost what the 5 megahertz CPU cost during the Lisa's development cycle, but the OS and all of the software was timed to the 5 megahertz clock, and it was then completely pointless to go back and re-engineer it all. So they shipped it with a 5 megahertz CPU and called it a day. That is one of the more major design flaws that's going to hamper some other stuff that we're going to see momentarily. As a result, everything is slow to draw on screen. Even in the Lisa operating system, when you're dragging windows around, it still stutters a bit. When you're rendering shapes with QuickDraw, it stutters a bit. That's not QuickDraw, that's the CPU. Because if you do the things on a Lisa, if you do the things that you were doing on a Lisa on a Macintosh, even like a 128K Macintosh, it's fast. Like it feels like it should. They wanted this to be like a mini computer. They really wanted this to be a workstation. So they gave it a design that was based around a backplane that allowed for modularity and expansion, which the Lisa has 3 expansion slots. And there were not a ton of expansion options at the start. You could get a dual parallel card. And that was about it. The nice thing was that meant you could attach multiple hard disks to it, multiple profile hard disks. Those were the only things that would really interact with this at the time. And that was about it. A little bit later on, there were some additional expansion options that came out. A quad serial card eventually hit the market in response to primarily Microsoft releasing Xenix for the Lisa. So this thing not only runs the Lisa operating system, it is capable of running Unix. Later on, it was capable of running the Mac OS, and until I think, a couple of years ago, Gem finally was released? Yeah, somebody dug up the prototype for release of Gem for the Lisa. Yes. Yeah, someone ported Gem to the Lisa, and it's compilable and it runs. You can run Gem on a Lisa. This may be the most robust computer in terms of what OSs you can install on it that Apple's ever made, just on number of OSs alone. Now we get to the memory. So the Lisa could support a maximum of 2 megabytes of memory. And in 1983, no one afforded 2 megabytes of memory. That was an obscene amount of RAM for 1982. But the RAM that was in here was very robust. It was all parity-based DRAM, and the way that the Lisa operating system and the ROM interacted with it, if a chip failed on either the upper or lower parts of RAM, LOS just ignored it. It just worked around it. Your system would not crash. LOS would recognize there was a fault, and it would just keep going, and it would ignore that particular segment of memory and just work around it. Which, again, not many other computers up to fairly recently were capable of doing something like that. The last major thing that they introduced were the Twiggies. They were Apple's proprietary 5¼ inch drive. They were terrible. They were horribly unreliable. They were, of course, proprietary because Apple. They were expensive. The drives had problems all the time. And when they released the Lisa 2, they would swap out your Twiggies for Sony 3.5 inch floppies for free. They were that notorious and unreliable. Which brings us up to 1983 going into 1984. Apple was fed up with Jobs' work on the Lisa project and his behavior in general. Spoiler alert, that will come back to bite him in the butt later on. As a result, he decided to take over the Macintosh development from Jeff Raskin, who I'm sure was not pleased by that because he co-opted a bunch of Jeff's designs, and then put the Macintosh team in direct competition with the Lisa team. The Lisa team also did not know that the Macintosh was under development. They had no idea it existed. The Macintosh was not 100% an inside secret, but people knew there was another project going on. They just didn't know what it was. It was the Macintosh. Bruce Daniels would come over from the Lisa and re-implement a lot of the interface technology into Mac OS, which is why the two actually kind of look similar. It's not identical, and we'll be powering some of these up, and we'll have some of them up. You can come by and see them at our table in the main hall. The interface feels familiar, like you've seen it in a dream before, but it's just unfamiliar enough that you know there's something off. This isn't Mac OS. Classical, which was developed for the Lisa, which was an implementation of Pascal on the Lisa, Tesler came over to the Mac team, and he worked on both sides after it kind of became public knowledge that the Macintosh was a thing, implemented his version of Pascal, classical, on the Macintosh, and that became Macintosh Object Pascal, which was the default development system for the Macintosh for a long time. If you were working on developing Mac apps in the early days of the Macintosh, you were developing them on a Lisa. Very little Mac app development was done on Macs leading up to the release and for a little while after of the Macintosh. However, the Osborne effect, which was a term that existed when all of this went down, news of the Macintosh hit the market before news of the Lisa hit the market. And the Macintosh was priced at, we'll see it in just a minute, it was priced at under $3,000. The retail price of the Lisa on January 1983, $10,000 in 1983 dollars. You could also get a 5 megabyte profile hard drive attached to your parallel port for another $3,500. So you're $13,500 plus tax in the hole for effectively an unreliable, because of its storage medium, and what, 30% slower Macintosh. For context, for $1,600 thereabouts, you could have a PC. For $2,500, you could have a Macintosh. For about $600, you could have a Commodore 64. And the Apple IIe, all decked out, just to the nines. Still a fraction of the cost of a Lisa. And I guarantee you, I don't know what the numbers are, but I would put money on there being way more Apple IIes sold in 83 and 84 than there were Lisas sold in 83 and 84. So we're going to go with take two, Electric Boogaloo. Lisa 1 was a failure. Let's try it again. So they released the Lisa 2 line, which was actually 3 different machines. There was just the flat Lisa 2, which was just the Lisa. No hard drive, just a unit, keyboard, mouse, and no expansion. That's it. And I believe 1 megabyte of RAM. They released that in January of 84. And you could get it, you could get it in 3 models. So it came with a 400K single-sided floppy drive, no hard disk, and a megabyte of RAM. The 2.5 had an external 5 megabyte profile that came with it, and a price tag that reflected it, obviously. And the 210 came with an internal 10 megabyte hard drive that was about as reliable as the Twiggies were. Widgets are, as I'm sure you can attest, they're very failure prone nowadays. They were fairly brittle when they were new. They're extremely brittle now. They fail if you look at them wrong. So the working ones that exist in the world today are not easy to come by. At this point, they also dropped the price tag on the Lisa to around $5,000. Just for the base model. That doesn't count, that doesn't include the profile as well. So $3,500 was the cheapest. $5,500 was for the 210. So for around $4,500, you were going to be able to get a Lisa with a profile. So it's 1985. The Lisa has sold terribly, and Apple has decided it's finally time to throw in the towel. Except, hey, I know, we can sell more Lisas if we just call it a Macintosh and write software that lets you run Mac OS on it, because it's basically a Macintosh that runs at a reduced speed. And so MacWorks was born. And MacWorks is incredibly simple. It basically patches the Lisa's ROM in RAM to run the Macintosh's boot ROM. Much of the hardware that the Lisa uses, the Macintosh also uses. The same serial IC controls serial communications. It has an IWM in it for floppy disk control. Its video system is not at all the same, but you just retool that code in ROM and you're probably going to be okay. So the first release was in 1984. All of a sudden, okay, cool, we can run Mac OS on a Lisa. The software sales for the Mac are infinitely greater than what they are for the Lisa. We can maybe hawk some software for people that have Lisas. However, the chicken finally came home to roost. It was a absolutely abysmal experience to use, especially on earlier versions of Mac OS that didn't have as many refinements as later ones would have. It was slow. It was a slow Macintosh, and the Macintosh was already not the best CPU out there. It was running at 8 megahertz, but now you're running it almost at half that speed. So it didn't go over all that well, and ultimately in 1986 the entire Lisa line was discontinued. It sold fewer than 10,000 units throughout its entire life. And the exact figure is unknown, but we do know it is less than 10,000. The OG Mac sold 50,000 units in the first 100 days it was on the market. That was it. That was the final nail in the coffin when everybody knew the Lisa's done. It's tanked. We're just going to eke what we can out of it and eventually pawn it off to somebody else. And so in 1987, they liquidated the remaining stock to Sun Remarketing out of Utah. And in 1989, Sun Remarketing decided, we're done. Nobody's buying any of this anymore. We're no longer going to support it. The remaining 2,700 units that Sun Remarketing had in stock were destroyed and disposed of in a secure landfill in Logan, Utah, not very far out of Provo, which is where Sun Remarketing was based. And that's it. That was it. The Lisa was officially done from a commercial viability standpoint. However, it did continue to enjoy aftermarket support for the Lisas that were still out there. So we weren't getting any new Lisas, but there were still people working on it. And Sun Remarketing would go on to buy up the license to MacWorks and expand upon it. Eventually, we'll talk about this in the next bullet point that's on here. Eventually, it would support all the way up to System 603, which was pretty far along. That, I think, came out in 89? Yeah. But they introduced a SCSI card that added SCSI support to the Lisa, so you could actually install MacWorks on a reliable SCSI hard disk and boot off the floppy and take it out, and you were in a Macintosh with a hard drive of however big you could afford to put in. And that made it a lot more lucrative if you owned a Lisa to keep using it, because you could just treat it like a Macintosh for a little bit more. The Lisa DAC, which insanely rare. There are some floating around out there. They're worth a fortune. It basically added the Macintosh's audio capacity to the Lisa. Not that you were doing much in terms of audio on the Macintosh in the late 80s unless you owned like a 2FX and ran a production studio or something like that. And eventually they also added support for an internal MFM hard drive. And you can actually find those. There's one,
I don't think we have one, but if you go over to the Edgar Digital table, the Lisa that he has there that he's trying to sell, if you ask him to take the front cover off, you can actually see one of those MFM drives.
Yeah. Query Engineering, which was another company that did work with Apple in designing MacWorks. James McPhail out of Canada was the guy that ran and pretty much single-handedly led up the effort to continue that support. He would expand on MacWorks for years to come. The two hardware developments that he also produced were the Accelerator, which there were 3 variants of that, and it basically, the minimum accelerator that you could attach to your Lisa would basically bump it up to a 16 megahertz 68,000, which meant this was now twice the speed of the Macintosh it was emulating. The PFG, the Programmable Frequency Generator, was also introduced to allow you to read 800K floppies that were formatted in all kinds of different Macs. So you were basically working with a Mac that was genuinely a Mac at this point. If you have a PFG, you don't need the accelerator, but if you have a PFG, the Lisa will run everything up to 753, which is insane to think about, that a machine introduced in 1983 could run an OS that was introduced in, I think, 1992 or 1993.
Yeah.
It's slow. 7.5 has a lot of bottlenecks in it. It uses a lot of system resources. But if you either performed a hardware mod on the Lisa itself, or if you had an accelerator, you could install, if you just had a hardware mod, you could install up to 4 megabytes of RAM, but you could never use the Lisa operating system again after that. You were stuck using MacWorks. If you had an accelerator, I think you could put up to 16 megabytes of RAM in. So you would have spent a lot of money by the time you were using those things, but you would have had a better Macintosh than the Macintosh. If anybody out there knows anybody that has either of those, let us know.
Oh, and can I add something before we continue?
Yes.
So Claire Engineering is actually still around. They
Yep.
go by Sigma 7 Systems now. So if you look that up, you'll be able to find James McPhail, and he still sells this stuff, actually, if you're interested.
Yes.
And also, one thing to note, this is probably kind of obvious, but with the accelerator, if you have one of those installed, you can no longer run the Office system or anything other than MacWorks, because you got a much faster CPU now. So
Yeah, once you step beyond 5 megahertz, none of the original Lisa software works anymore. Nothing. Sun and, I believe, Cherokee was the company that eventually bought them out. They would continue offering Lisa support into the late 90s. That Lisa right there, which is mine, the gentleman that I originally acquired that from last year, that was his daily driver of a computer from the day he bought it new in 83 or 84 to 1998, I believe. Until he finally had to use a modern computer because the internet was requiring him to do email. That is what finally got him off of that and onto a modern Windows machine. I would lose my mind if I had to do that. And now we kind of get up to current day. The Lisa was kind of shunned. Nobody really had any interest in them. However, scarcity breeds collectivity. As more and more people started to throw them away, oh, hey, wow, Lisas are really hard to find. I remember using one of those. Maybe I can find one eventually. Oh, hey, here's one that I've had in my back office forever. Things like that started working their way back out onto the market, and they went from, oh, hey, I can probably find one of these for $50 somewhere, to, oh, wow, these are actually kind of rare. You know, maybe I can get a couple $100 for one, to, if you go on eBay now, they're in the several thousands of dollars, and just, it's insane. But there aren't a ton of them floating around anymore. I mean, these are incredibly scarce machines, unfortunately, which has then, in turn, led to reproduction efforts to preserve hardware that the Lisa used, because it's 40 years old now, and some of that stuff is, if not hard to find, you just can't find it. It's not out there. There are a few places where you can still generally find some parts. Vintage Micros is a good place online that does have some Lisa part stock left over, but not a ton.
And they're also very expensive.
And we will actually circle back to the reproduction effort here towards the end of the conversation. And then back in January, Apple, under one of the most bizarre license agreements ever produced, they released the LOS source code. So you can actually go to the Computer History Museum's website, agree to, again, one of the most bizarre license agreements you'll ever read. It basically entitles you to one copy of the Lisa source code that you cannot share with anyone. You can make changes to for your own personal use, but you cannot share those code changes with anyone else. You can describe the changes and what they do, but it is a violation of the license agreement to give your code that you have developed that modifies the LOS source code to anyone else. Also, within about 5 seconds of the code showing up on CHM's website, there were like 50 GitHub repos that were opened. And Al Caso, who is the Computer History Museum's curator for a lot of their Apple stuff, somebody on Lisa List, the Lisa forums, posted, oh yeah, here's somebody already has uploaded it to GitHub. His response on the forum was just a frowny face, because he was the guy that like spearheaded all of the efforts to get Apple to actually release that. And that was a little disappointing for him, but maybe anticipate things like that when you're releasing the source code to a 40-year-old computer that there's an incredibly niche community centered around. Lisa List obviously is kind of the central hub that a lot of the conversation and development for Lisa stuff goes on in. And as of now, and we'll come back to this at the end of the presentation, the card stack that runs the Lisa, the brain of the Lisa, has been completely reproduced. If you want to build a Lisa from scratch, you can. Someone already has. DOSFox, if you follow them on Twitter, they live in Britain, has already rebuilt one from new parts. And I have not talked to them in a couple of months. My wife and I had our first kid 3 months ago, so I've been a little slow on communicating with people. Thank you. Sorry, that was not a shameless plug. I apologize.
What clock does that run at?
5 megahertz. Yeah. Also, there is a microcontroller on the I/O board that is unobtainium. The Lisa does not work without it. However, Schaefer?
Yeah.
Yeah, Patrick Schaefer, German fellow, brilliant electrical engineer, discovered, oh hey, the COP 400 is a ROM-less version of the mask microcontroller in here. Maybe I can just trick it into spitting out the contents of its mask ROM, and I can just burn that to an EPROM and connect it and see if it works. And it did. And COP 400s are actually still available. You can get them on eBay for like $10. I have one. It works flawlessly. So there's still a really vibrant community of people working on preserving this hardware, despite the fact that it's arguably a piece of crap. That now catches us up to current day, and I'm going to hand everything over to Alex to take the reins and talk about the more technical aspects of the Lisa that I have a hard time understanding.
All right, so yeah, let's talk about the actual architecture of the Lisa now. And so I want to actually show the boards that I'm talking about while we go over the Lisa's hardware. So I'm going to take, oh come on, my fingers are too sweaty to open the... Thank you. Okay.
There you go.
So I have just taken the back off of the Lisa. It's actually really easy to open. It's just got these two convenient little thumb screws on it. You just twist them and pop the back right off of the computer. So yeah, if only Apple still made things like that, that would be really awesome. But the card cage on the back, I can't really turn around to show you, but the card cage is just this big thing that slides into the back of the Lisa with all of the actual hardware in it.
Which,
so,
I'm going to interrupt you a second. Real missed opportunity on Apple's part to call it a card deck.
Yes, that would have been great. But yep, here is the card cage. So now we can actually start talking about the boards that are in it, and I can actually show them to you. So I think Will mentioned this earlier, but the design is a lot like a mini computer in that it's not just all one board. It's actually a bunch of different boards that plug into a common backplane that just interconnects all of the other boards together. And that is because a lot of the engineers who designed the Lisa used to work for other companies like HP who specialize in designing mini computers. So they brought a lot of that knowledge over to the Lisa, and you'll notice that a lot of aspects of the Lisa's design, not just that, are all inspired by the design of a lot of mini computers at the time. And so the four main boards that are in the Lisa are the CPU board, which, as the name implies, holds the processor itself, among other things. Then we have the I/O board, which is right here. I'll turn around and show the actual components to you in a minute, which handles input and output. And then we have two memory boards right here, and there's another one that you can't really see back here, but they're identical, and well, they contain the system's 1 megabyte of memory. And the backplane, it's not just called the backplane. For some reason, they call it the motherboard instead, which is a little bit confusing because normally you think of that as the board that has all the components on it. But in this case, it has like practically no components on it. It's just a board that connects stuff. So yeah, that's the motherboard. And then, as I said, this whole thing is called the card cage because it's a cage that holds all of the cards. And I think Will kind of talked about this earlier too, but I wanted to actually show the hard drives that the Lisa supported. So first, we have the profile down here. Oh, well, microphone came off. Can you hold this for a second? I'm sorry, guys. I'm very clumsy sometimes, and it is clearly showing.
That one's dead.
Oh, that's the dead one. Oh, excellent. Okay, cool. Well,
Oh, here, hang on.
oh God, it's tangled.
What have you done?
I'm sorry, I am very clumsy, so I apologize for that. It's a miracle I haven't broken the Lisa in some way. But, well, here is the profile. So this drive came with the Lisa 1, which is the Lisa that had the Twiggy drives, as well as the Lisa 2.5. And it's, well, a gigantic hard drive that stores 5 megabytes of data. And so the power supply, the disk itself, and a control board are all in this gigantic package here. So that's one hard drive option that was available. And then we also have in the Lisa 210, we have this drive here called the widget. And this is it's an internal drive. You can see it would actually fit perfectly right in here in the front of the Lisa. And this holds 10 megabytes, and it was very ahead of its time in a lot of ways. It uses servo positioning, voice coils instead of a stepper motor for moving the heads. It's really advanced. It's got some really cool like error correction stuff built in. It's a very advanced drive, but they're also super unreliable. So that's the widget. And then this, I just brought this because it's kind of cool. This is, what were you were pointing at something?
I think you had a question. Is that what brand does that make?
The widget?
Yeah.
It's completely custom. Apple, it was like everything. The HDA itself was custom. Everything about it was custom. Literally everything. It was a product of, not invented here syndrome. So literally everything about it, which makes it a huge pain to repair because you can't get replacement parts very easily since they're all entirely custom. But this is really cool. I just kind of brought this because it's neat, but it's not in the PowerPoint. But this is actually a prototype that I have of the widget. So it kind of combines the profile and the widget together in terms of the architecture of the hard drive. But it fits internally in the Lisa. And as far as I'm aware, this is the only one of these in existence, and it works. So it's a pretty cool drive. I just figured I would show that because why not? And now we can move on to actually talking about each one of the cards in more detail. But first, let's talk about the power supply. So the power supply actually slides out of the back of the Lisa a lot like the card cage does. We just loosen this little screw here and ta-da! Very modular. This is the entire power supply, and you can see it has a little card edge connector on here that slots into the chassis of the Lisa to provide power to everything. And it's a really cool power supply in a lot of ways. So it supplies all the voltages the Lisa needs, which is the standard plus and minus 5, plus and minus 12. But then it also supplies 33 volts, which is used by the Lisa's video circuitry. Very low current, but 33 volts. And then it also generates a 5 volt standby voltage, also very low current. But this is kind of cool because the Lisa actually supports soft power, unlike pretty much every other computer released at the time. Like the Mac, I don't think supported it until the Macintosh 2 maybe. So yeah, so a lot later. And the PC didn't support it for quite a while. So this power supply actually supports soft power, and the 5 volt standby supply, well, it's a standby supply, so it's always on when the Lisa is plugged in, even if soft power is off, right? So that allows the Lisa to still keep, the time and keep parameter RAM even while the rest of the system is powered off. And there are two different variants of the power supply. There's the awful, absolutely terrible, throw it away if you have one, Apple 1.2 amp supply. And then there's the awesome Data Power 1.8 amp supply. And so the Apple supply, it was completely designed by Apple along with Aztec, who designed a lot of the Apple II, Apple III power supplies, all that. It's awful. I've had like 3 of them over the years, and Will has had one too, and none of them work. Like, we just can't get them to work. They are so annoying. But those came in the Lisa 1 and the Lisa 2.5. But then when the Lisa 210 came around, well, this power supply also had to power an internal hard disk. So they upgraded to a 1.8 amp supply made by a completely different company called Data Power. And that's what I have here. These are super reliable. I don't think I've ever had one of these fail. So these are really cool supplies. And power supply, for whatever reason, this doesn't make any sense, but it also contains the brightness and focus adjustment potentiometers, which stick like way out of the back. And they are not connected to any of the hardware inside the supply at all. They're just routed straight to the edge connector. But yeah, for whatever reason, they decided to put those 2 pots inside the power supply. And then, in a very Apple move, there's also an interlock switch on the back. You can see it right here through that little hole. And the Lisa will refuse to turn on unless this switch is engaged. And it's engaged by having the cover on, which presses through this little hole. And yeah, there's one here on the back, and there's another one on the front under the front panel. And if those switches aren't engaged, the Lisa will not turn on. So it's pretty stupid, but I bypassed it on all this because I don't want to have to deal with that. So that's the power supply. And now we can talk about the motherboard. I can't really show you the actual motherboard because I have to take all the cards out, and that's a bit of a pain. But here is a prototype. We're going to talk about this later, but we replicated a lot of the cards in the card stack. This is a replica of the motherboard. So that's what sits down at the bottom. As I said, it's a back plane, but it also contains it contains a couple other interesting things too. So if we look on the actual motherboard that's installed here, you can see that it actually has both of the Lisa serial ports, as well as the mouse port, and a composite video output, which does not work with like really any monitor in existence because it uses a really weird refresh rate. So that's kind of useless, but it's on there. And then it also has a reset button, which, well, sends a reset signal to the processor. Let's see what else. Yeah, the Lisa 1 and Lisa 2.5 also have a parallel port. This is a Lisa 210, so it does not have the parallel port here. But the 1 and the 2.5 have a parallel port. It looks just like the serial ports, but it's a parallel port, and that would allow you to connect an external hard drive, like a profile, to the Lisa. But the 210, since it has a built-in hard drive, you don't really need that. And it's already used anyway because it's being routed internally. And then the 210, since it doesn't have that parallel port, they had a little more room, so they added an interrupt button, which it's non-maskable interrupt, just like what you'd find the programmer switch on a Mac. Reset and interrupt, just like that. And then it also has two edge connectors over here. It's a little easier to see on the replica. These two edge connectors here slide into the back of the Lisa and actually connect all of the cards to the other stuff in the Lisa. So this connector over here mainly handles the floppy drive, the keyboard, things like that. Whereas this connector over here handles power and video. And on the 210, this connector here also handles the hard drive, since there's an internal hard drive. So it's got a little more on it on the 210 than it does on the 2.5. And yeah, as I said, it's pretty inert in terms of what it actually does. It basically just connects stuff together. But it also has a couple cool expansion slots on it, which are over here. And that allows you to put these really weird shaped expansion cards into your Lisa. If only Apple still allowed you to do this. But they're really cool because in order to get a card in and out, they're actually ZIF sockets, believe it or not. So you pull out on this little lever here, and then you twist it to the side, and it spreads the socket apart, allowing you to slide your card out. And yeah, that's how you install a card. You just open the ZIF lever, slide it in, close it, push it in.
It should be noted, that was designed by Apple.
Yeah.
And if you've ever seen the meme of Apple regarding innovation, who was it? Was it Phil, what's his face, that said,
yeah, Phil Schiller.
Said, can't innovate anymore, my ass? That might be one of the crappiest innovations Apple's ever come up with. They break. Why would you do that?
And they break all the time. And
yeah.
The connector is completely custom, so if they break, I'm sorry, you can't get a new one. Luckily, these aren't broken, but most of them are. So now the CPU board. That is what this is here. So as the name implies, it has the CPU itself, the 68000, which is the big, cool purple and gold ceramic chip up here, along with a bunch of associated glue logic, error handling stuff, just a bunch of random stuff related to the processor, basically. And the CPU board is actually identical between all models of the Lisa. Other than the ROMs. The ROMs here are going to be a little different depending on which Lisa you have. Like some of these ROMs will support Twiggy drives, some won't. Some just have updates to them that are useful for running MacWorks, like screen resolution stuff. Yeah. And then as we said, the CPU is clocked at 5 megahertz, so pretty slow. And then the two boot ROMs that, well, boot and run diagnostics on the system are these two chips right here. They are 2764s, I believe. And then it also has the Lisa's MMU on it, which is, as I said, or as Will said earlier, very confusing. So we're not going to explain how that works because I don't understand it.
You don't know.
But yeah, we just don't know. It's magic. But these three chips up here are the registers that hold all the configuration information for the MMU. So at least we can point that out, right? And it also contains the video generation circuitry. So that all revolves around this ROM right here, which basically forms a state machine for the horizontal and vertical sync signals. And you can actually swap this out because the Lisa screen resolution is different, and the aspect ratio is different from that of the Mac. So there was an upgrade, a screen mod upgrade, where you could swap this out for a different chip and swap the ROMs out for different ROMs that actually adjust the screen to make it look better in MacWorks. But then you can't run the Lisa Office system anymore. It looks absolutely awful. So that's an upgrade you can do. And for whatever reason, they also decide to put a serial number for the computer in the video ROM for some reason. I don't know why. And the Office system has DRM. So when you try to install applications on your Lisa, it serializes them to your Lisa. So if you move your hard drive to another one, it reads that Lisa serial number. It doesn't match, so they won't run. And to make matters worse, when you copy the applications over, it also serializes the disks themselves. So now you can't even use the disks to install it on a different Lisa, which is awful. And then it also has our main 5 megahertz clock dividers for everything, error and status registers, pretty much anything CPU related, as well as glue logic. Yep.
How static sensitive are these components?
Well, I've never had one fail thanks to static, so I don't know. But not super sensitive, I guess.
If you're Raymond Jett, the answer is very. If you're either of us, the answer is, well, we've probably shocked them a couple of times and fed, unfortunately, high voltages into these things.
Yeah, they've been fine. So yeah. Somewhat resistant, it seems. So then we got the memory boards here, which they're completely identical, so I'm just going to show one. But this is the RAM board. It literally just contains the RAM. That's what all of these chips on the sides are. The middle stuff is different, but everything on these sides is just RAM chips. And these, just like the CPU board, they're identical between all Lisa models, unless you get a RAM upgrade, but that's a different story. And each board is 512K, so we need 2 of them for the full 1 meg. The Lisa will run with just 1, but then it has to start using the disk as swap space, and well, that's really, really slow, so don't do that. Go with the full 1 meg. And it uses 64K by 1-bit RAM chips, so we need a whole lot of chips to build up to the full 512K and then the full 1 meg. And we also have parity chips on the end. If you count here, you can see it's 1, 2, 3, 4, 5, 6, 7, 8, 9 chips instead of just 8. So those last chips on both the high and the low byte are for parity, and that parity is automatically generated and checked by LS280 parity generator and checker chips, which is pretty cool. And yeah, and then with a third-party upgrade, as Will mentioned, you can get up to 4 megs of RAM. 2 megs by default and 4 megs after some modifications. But you can get some pretty big amounts of RAM in this thing if you want to. And then finally,
We got about 5 minutes.
oh shoot, really?
Yeah.
Oh no, okay. I'm really bad at being concise, so let's see what happens. Okay, so last up is the I/O board. So as the name implies, this does input-output stuff for the Lisa. So all the ports on the back are controlled by this. And this is the board that's like completely different between the 1 and the 2.5 and then the 2.10. So this is the I/O board from the 2.10. The I/O board from the 2.5. I don't have a populated, actually I don't even have a blank one on hand, but it looks, you can see it on the screen there. That's what the 2.5 I/O board looks like, but these are completely different between the two. The Lisa 1 and the Lisa 2.5 use the same board, just with a different floppy controller ROM, and there are a couple resistors that get cut when you switch from Twiggy drives to the 400K drive, but that's the only difference between those two. And then it has a floppy controller on it that, well, makes the CPU board's job a whole lot easier because it doesn't have to micromanage all the floppy operations. This board actually has a 6504 processor, which is basically a 6502 just with a reduced address space. They're basically like the exact same thing. Well, the CPU can put commands into shared RAM that is shared between the 6504 and the 68000 to command it to read a particular sector off the floppy. And then the return data will just be stored in that RAM, and the CPU will get an interrupt, and it can go and read that data out. So it greatly simplifies the floppy disk operations, which is pretty cool. And the Lisa 1 and Lisa 2.5 I/O boards, the whole floppy controller state machine is made completely out of like discrete logic. But on the 210, they upgraded to the IWM, just like what the Mac uses, which condenses a lot of stuff. And the IWM is this chip right here. on the 210 board. So that's kind of cool. And that same shared RAM that is shared between the 68000 and the 6504, that is also used for the system's parameter RAM. So it's also battery backed. So when you unplug the system, there's a battery that will keep that, and also the 5-volt standby power will keep the contents of that memory if you don't have if the system's actually plugged into the wall.
Also, the
yeah.
batteries will leak and kill your Lisa, which was part of the impetus for us working on
Yes.
reverse engineering some of this hardware.
Yes, they are absolutely terrible. They suck.
No.
Well, if you
Yes.
if you desolder them, yes, but they go right here. It's 4 AA's, rechargeable AA's hooked up in series, and they just go right here. They leak everywhere. Yeah, what else? So this also has the hard disk controller on it. It just uses a 6522 VIA. Pretty simple, nothing really to say. It just implements the weird protocol that the profile and widget use. It also has the audio generation circuitry, and the Lisa, you can actually adjust the volume of the speaker coming out of the Lisa with a little resistor network on here. So software controllable volume, which is cool. Also, this has software controllable contrast on this board, so you can actually adjust the contrast of the screen in software instead of having a little knob to do it, which is pretty darn cool for the time. And then it also controls keyboard, mouse, real-time clock, all that, and that is through that COP 421 chip that Will was talking about that's impossible to find because it uses a mask ROM. That is this chip right here. And it handles all that and just forwards the result to the actual 68000. Once again, taking a little more load off of the actual CPU. So I guess the Lisa in total has like 3 coprocessors, well, 2 coprocessors plus a 68000, which is kind of cool. And then it also, serial ports are controlled by an 8530, just like on the Macintosh. So that's really it for the I/O board. And now we can look at the boards that we have actually replicated. So we've gone through, and between the two of us, we have replicated every single board in this entire card cage, plus some expansion cards.
I tell you what, if you want to set up the demo.
Oh, yeah, I'll set up the
I
demo.
know
And
some cards,
yes.
So these are live boards, or they're just display replicas?
No, they're functional.
They're functional. They don't have parts in them, but they work.
Yeah, these are non-populated, obviously, but this is the reproduction CPU card. This was about 3 or 4 months of work to hand draw every trace identical to the original. This is effectively a one-to-one replacement. This actually has one error in it that I have since corrected. A set of these boards will be available in the auction this evening. The CPU board, if you win the auction, is one of the correct ones. It's not one of these. So, yeah, this is a 4-layer board, and boy howdy, there is a lot of work that went into understanding how EDA software works on both of our parts to step up to something this complex. The I/O card, if I can find that.
Oh, yeah, I'm not sure if we have.
Okay.
Look in there. I think there might be one somewhere. Oh, yeah, there's one. There's one. Okay.
Here is the reproduction I/O card. It does have the power circuitry on it. So if you did want to use rechargeable batteries with it, you could. Please don't. There's a reason why we built these. It was not so you could destroy them again.
Yeah, I haven't even tested the battery charging circuitry on that board, so I don't even know if it works, but I don't want to find out.
And I don't think I have one in here, but because the 1.2 amp power supplies are so terribly unreliable, we also have this is not it, I apologize. We also have an ATX, a Pico ATX based PSU replacement that uses off-the-shelf stock parts that you can get from Mouser, DigiKey, Amazon. For about $60, you can completely replace the 1.2 amp failure-prone PSU in your Lisa, if you have one, with one of these that actually will last and not just blow out on you some Tuesday afternoon. So, you ready to go?
Yeah, I think I'm ready to show the little demo. But yeah, we designed all those boards. There are a couple others too that we might just want to show. I made this little power supply tester.
Oh, yeah.
You just plug straight into the edge connector on the power supply, and you flip the switch to control soft power to test your supply without risking damage to your Lisa.
So,
yeah,
we're out of time.
Oh, we're actually. Oh,
yeah,
shoot.
we're actually
okay,
out of time.
I'm sorry.
So,
I thought we were just pressed. But
no, that's all right. That's all right.
Well, this demo, it's kind of stupid, but it's just a fun little program I wrote in assembly language for the Lisa that will play MIDI files on the Lisa's speaker. It's all just one voice, really simple, just beeper stuff. But yeah, let's listen to it. Ready? Give it a second to load, and does nobody recognize it?
Nice.
Okay, there you go. Okay, someone recognized it. So yeah,
Very good.
you can hear that the audio capabilities are not very impressive, but there you go.
Rick Astley.
Do we want to show MacWorks too, or
No, we're
we
good
don't
on time. We're good on
Okay.
time.
So we don't have time for the other thing we were going to show. But
Thank you very much for coming out, everybody. So.